When you place an online order, let's say at Amazon, do you know 25 to 35% of what you're paying for goes into the operating costs of the warehouse? Picking, packing, fulfillment, the site operations, everything to do with the warehouse. That is especially true for smaller players, which make up a large percentage of what's happening on online commerce. Could we automate those smaller players? Would that bring the cost down for the consumer, such as you and I? That's the intriguing question I want to explore with my next guest, Igor. He's the CEO of InStock.com, and he's got a robotic solution for micro-fulfillment centers. I want to understand how lightweight magnetic robots that he's deploying for smaller players can use the vertical space, how he uses digital twins to quickly map out smaller locations such as back rooms of retail stores and warehouses. Would that lower cost translate to lower prices for the consumer? How does the fast deployment work? What does the future of commerce look like? What does automation feel like and can be deployed at scale for those smaller spaces, 1,000 square foot or less? That's what I want to learn about, and that's what we want to bring on this episode of Robot Builders Club. Get ready to see logistics and micro-fulfillment in a new lens. See how a squad of robots adapt to vertical heights and bring automation to the industry. If you're a founder, operator, innovator, engineer, or just somebody who's interested in leveraging hardware, software to disrupt this conversation, is going to make a lot of sense to you. I'm Ali Afzal, and this is Robot Builders Club. Let's dive in. Mr. Igor, welcome to Robot Builders Club. Thank you for giving me your time.
Yeah, pleasure.
So I'll jump straight into it. So much to talk about, so much to unpack on automated storage and retrieval systems, micro-fulfillment, all of that good stuff. Would it be fair to say that you're in the business of letting us use that vertical space cheaply and flexibly? You're thinking warehouse should be smaller, footprint should be smaller. Let's realize micro-fulfillment in a more efficient way.
That's well said. I want to democratize and open storage and retrieval, not only for huge warehouses, but also for small spaces.
Got it. And why hasn't anyone cracked this before? If it seems like idea is obvious that let's use the vertical space, let's make the footprint smaller. Why haven't the legacy automated storage and retrieval systems been able to crack it?
Yeah, I mean, you are totally right. It is obvious. It is on the surface, but it's very hard to implement. And one thing to realize is that the economics of maintenance of such a system is very different when you compare a huge, say, 300 square feet warehouse where automation occupies half of it, and let's say a smaller space where storage may take only 2,000 square feet. So economics is different, and it just doesn't work with those old school conservative systems in the small spaces.
So in your solution, does it yield us into smaller SKUs, items that are not as large?
Not necessarily. You may serve the same type of items, right? Whatever fits into a plastic bin, but the change is more in how you implement the system, what is necessary to maintain it. One thing to just recognize is that whether this is an automation hardware, some kind of robot, or any piece of hardware, like you have only very few options in terms of maintenance. What happens when things go down? Like what happens when it breaks, right? I love the analogy of the things you have in your kitchen, right? You have fridges, dishwashers, toasters, coffee makers, and maybe you have a laptop and your phone in your kitchen, right? And these three groups of hardware, they actually demonstrate the whole universe of what can happen with hardware, right? When hardware goes down, the options are you're either inviting someone to fix it, you are getting the item yourself to the place where it can be fixed, right? Or you're throwing away, you're disposing the item. There are no other options. It doesn't matter what kind of hardware that is. Is it a robot or just some dumb toaster? And when you think about automation and a system like storage and retrieval, the question becomes, okay, what do you do when something goes down? The old systems, they are in the category of fridges, right? You have to invite someone. it's too heavy to do
Mm.
anything about it. There are no robots nowadays in storage and retrieval that are in the category of toasters that you can just dispose of the robot and let's say insert the next one. So what we are doing, we are moving the system from fridges to the category of laptops, category of phones, where not necessarily you throw away and dispose the item, but you can send the item, you can drive the item, you can move it to a place where it can be fixed, to some kind of central service facility. And this operation is still economical and produces nice unit economics, both for the customer and for the vendor.
The picture that you're painting of the warehouse, that is that future fundamentally different from what is currently in place, in the sense that when we think of warehouses, we're thinking of large spaces, pallets with forklifts moving and picking happening either through human, or even if it's automated, these are large, clunky, like you said, refrigerators that are moving around. Do you think, in your vision of the future, we're moving from that large sort of refrigerator warehouse world to smaller space
It's
with
not that we are
toaster?
moving away from warehouses, right? We just bringing automation where it never was, right? You never had a chance to automate something small, like a small storage room for items and parts in manufacturing, right? Or in a small setting of third-party logistics company. Or a small back room of a store of fulfillment, whether this is e-commerce or you maybe are picking something to bring to your shelf in the front of the store. Those operations were and are still manual. That's what we're changing, right? The warehouses will stay. They have their own economy of scale and it will not going away, but we can bring automation to much smaller spaces. And of course, you have enormous number of those spaces. The quantity of facility, like the number of facilities where you can automate and that are completely manual is just staggering. We're talking about
Okay.
hundreds of thousands of rooms in North America.
Understood. Okay. No, that makes it clear. So you're not going after the central fulfillment center. You're saying let's bring automation to the smaller spaces where that are closer to the customer.
Yeah. Yeah. Another loose analogy is how computers were evolving, right? You had mainframes and they were centralized and very few, very big. Then you got personal computer, and then the technologies of small personal computer, then they went back into the data center. And now again, in data center, you have such beasts that you will never install. So here we have a little bit same evolution, but with a big difference that time-wise, automation, industrial automation, is still in the age of mainframes.
Got it.
So this
Yeah.
personal robotics is still yet to happen.
Got it. Yeah. And you're working with operators, you're talking to your customers. What frustration or what problems that you're noticing where you said, oh, the system is fundamentally flawed, or there's opportunity here? What are these, some of these problems that they have currently that you're solving?
Yeah, I think the operators have the number one feedback that operators and many people who tried new kinds of robotics, what they have is like they are excited about new things, but for 5 minutes. And after
Mm.
that, there is a reality that things must work and they must fit well into processes and they should be understandable enough, digestible enough to let people get out of edge cases of some situations that were not considered when you thought about like vanilla flow. So and this flexibility, that is something that is missing in a number of systems. So when you are deploying, you have to think through like, okay, what happens when things go not as planned? I heard one estimate, I worked with a company from Austria called Knapp, which is a very traditional, conservative, very good automation company. And one guy from there said that 70% of their code is about edge cases and some kind of irregular situations. So, like when 70% of your code is
Mm.
about something irregular, it becomes very regular. So what you mostly are working on is not vanilla flow. It's what happens when things do not go as planned.
And it's a lot of things breaking, a lot of exception
Things
handling.
will break, right? But that should not produce harm or catastrophic effects or some kind of dramatic loss of productivity. You want things to maybe kind of smoothly and elastically go down in productivity if there is a real hardware failure, and then go back up. And you want elasticity generally in your operations. You want operators to be able to drive productivity up and down by deploying one more robot, right? Or taking out one more robot that is in the way of other robots and is faulty. So you want to enable operator and make those operations simple enough so that operators can actually do them.
And let's take a step back from taking a look at a broader view. You're the CEO of this company. You've deployed this technology. You're going into commercial. Let's say you win. Your technology gets adopted everywhere. What is the grand vision? What does the world look like if this is adopted on a mass scale? What do we get out of this, your robotic system? What changes how physical goods move? What is the impact?
The impact is that operators think much less about how to organize their space efficiently. More or less, the effect that was produced by racks and forklifts on the warehouses. When you're building a warehouse today, like there is no question, do I need racks or I don't need racks? If you want to store pallets, of course, you go for racks. They're more or less standardized, and and you use all kinds of forklifts that are available. And there is there is a very good compatibility between forklifts and your pallets and your rack.
Hmm.
So somewhat along those lines should happen in small spaces. So when you have, say, 1,000 square feet to organize for storage, you don't think like it's cheap enough, it's effective. You don't have to jump over multiple permitting kind of barriers. You just don't think you deploy it and it works. It just drives bins for you. And then it also integrates with other types of automation, whether these are humanoids or picking arms, doesn't matter. It should fit well, and the interoperability should not produce kind of gray hair in operators.
Yeah. Why why did you decide, if we're talking about the system design that your company took, where the form factor that you landed on, why did you decide that you needed to um, organize the whole, make the whole system for the space? Why not just one part of it? It is harder to think of all of the things that would have to be designed in a warehouse, right? So trying to understand the
Well,
design side of
again,
things.
storage and retrieval in the micro fulfillment setting is one of the parts. It's not everything, right? You still have to do packing or like handover of the picked order to a courier or any kind of delivery system. So, but that's a big part and an important part. And I'm coming from a grocery delivery world. Back in the day in 2010, I started the company that was doing actually grocery delivery, something like Instacart. Before Instacart, on the East Coast, we were under the brand Cart Fresh. So, like after launching 30 sites with dozens and dozens of retailers and like managing hundreds of people. The beginning of that company was in Ukraine, and then I expanded to the East Coast. So, but supermarkets in Ukraine, they look exactly as supermarkets on the East Coast. Like there's no big difference. Same items, same time of operations. Um, After like managing of hundreds of people and basically many millions of dollars of GMV of turnover of those goods, this problem is just screaming, right? It's you see how you spend time and money on people walking around searching for items. That's what you do when you go to supermarket, right? You are like browsing aisles. If it's a store that is very known to you, then you kind of have already navigation in your head, a route, you go from one shelf to another. You think you are efficient, but all of that travel time can be substituted by robots, right? You have, and that can be done very cost efficiently. So it always kind of was obvious to me that, okay, how do we do that? But we have to do this in those small spaces, in the supermarkets, in the back rooms of supermarkets, or small manufacturing facility. And After trying a number of solutions, and for a number of years, I was working with Knapp within the company called Takeoff Technologies. It was one of the pioneers of micro fulfillment. I saw what are the challenges of traditional automation in this micro fulfillment setting. So I just realized that there is no way how you can improve things dramatically, radically by fine tuning what exists now. You basically have to redesign a couple of the core architectural components, and the maintainability and the ease of installation and ease of various operations with the system, they should be put into the cornerstone of your architecture.
Got it. I'm very interested in the solution that you've are deploying. I was looking at the video and I'll overlay it for the viewers. You have the robot and it goes up the ramp and up onto the ceiling, right? How is it? Walk us a little bit through that. How is it sticking? Is it magnetic? Why did you
Yes.
make that decision that it needed to go upside down as opposed to something that's already on top that's picking and
Well,
dropping it off?
yeah.
Walk us through that solution.
This was a super straightforward decision process. So you know that in the robotics, one of the hardest part is where you have a touch. It's where some actuator is touching something else. The usual example is a wheel that is touching a surface. It's hard to control a wheel if it's unpredictable surface and you may have skid. It's a science, right? So this is a hard part, and you don't want to ask operator to deploy the robot by climbing to some kind of mezzanine, by using some kind of jig, by dragging 200-pound robot. So the question we posed to ourselves was, if we have a weight limit for the robot, let's say 70 pounds, and we want robot to operate in the three-dimensional structure, and we want people to deploy the robot from the ground level conveniently, right? Then what kind of physical principles and mechanisms we can use? And we don't want to spend $1 billion on some very sophisticated model of a kind of reality. So our grid is very imperfect, right? Like we know that racks are imperfect, and we will build imperfect grids. There will be no tight tolerances and so on. Because for you to realize, the tolerances, they cost money. The tight tolerances are expensive in everything, in manufacturing, in transportation, in installation, and in maintenance. And the permanent magnets in the robot, that's a principle we landed on. And it works pretty well, right? It took us several years to figure out exactly like what is a composition, what combination of parts works well. But once we arrived to this good combination, right now it's kind of obvious that this is a very cost-effective way how you can create a lightweight, compact robot that can drive freely in sort of loosely defined, no tight tolerance environment, right? It's just like metal sheets, and they can have gaps or ridges or steps within that structure, but it still will drive because it will adapt using magnetic force to this environment. At the same time, it is safe due to permanent magnets, right? The permanent magnetism is free. Like once you, of course, purchase the magnet, it is free. It's kind of a little bit counterintuitive that something may be sticking to a ceiling for half a year, turned off, power off, right? And it's there for free without spending an energy. But yeah, like we take gravity for granted, but for some reason we don't want to take magnetism for granted. Yeah, but it's free.
That's a very interesting point. So I would have assumed you're using some sort of electromagnetism. How do you disengage when it comes down? Isn't that making the robot heavier, or are you able to pull?
You don't disengage. The simple thing is the floors have metal surface further away from a magnet than the ceiling. When you're driving on a ceiling or a vertical wall, you're essentially driving on the ferromagnetic surface, just metal sheets. Once you get down to the floor is of plywood or any other material.
Okay,
and
fair.
then of course, like if it's let's say it's a multi-level system like I have behind me, when you're on the floor of level 4, right, the ceiling of level 3 is under you, but the distance to the metal sheet of the ceiling of level 3 is higher, is larger. and therefore the pull on the floor is not that strong. But there is some pull. And it also gives you a way how you can drive on very curved surfaces. This can be a workstation or some kind of ramp. Just make it out of metal, and then the robot can climb. If it wouldn't be out of metal, then it will just tip over. Because remember, like the robot has a small wheelbase. This wheelbase is actually, the footprint is much smaller than the bin that it's carrying. So it's kind of, it's looking as it always wants to tip over, but it doesn't, because it has this pull near the wheels.
Got it. And choosing the magnet, that must put some constraints for how much the robot can carry, right?
Yes. Yes.
So, and what limit?
So we have a couple of settings. One is 60 pounds. So this is for a grocery case. Basically, you can have 6 gallons of milk in one bin, which is pretty heavy. And for like lighter 3PL, let's say it's apparel or some small items, necessarily of liquids or of metals, then this would be 40 pounds. But that's enough
Okay.
to cover
Yeah.
95% of all e-commerce transactions, be it on the dollar basis or on the weight basis.
Yeah.
Of course,
So
you always have like furniture, sports equipment, something that doesn't fit even into a bin,
yeah.
but the bin volume is limited. If it fits, to make it heavier than 60 pounds, you really have to pour liquid into it.
Got it. And yeah, that should, for a micro fulfillment, that's good enough specs. Yeah.
Yeah.
For you mentioned free magnetism, right? And nothing is for free. Getting that free magnet, what are you giving up? Is it speed? What are some of the constraints that making that decision of adopting magnetism puts on
Well,
your robot?
of course, on a ceiling, it can drive only on a ferromagnetic surface. So a ceiling must be of iron, metal, and that's somewhat a constraint, you may say. But you are not really giving up much. When it drives on the floor, it can be as fast, as quick as any other robot. The additional force, if you can control it, right? And the way you can control it is by, first of all, you may move a magnet further or closer away from a surface. But this additional force give you additional degree of freedom to control your robot. So if you want to move magnet further, closer away from a surface, this mechanism costs. So let's say it adds another $1,000 to the BOM of your robot. That's what you are paying for. The magnets themselves, they're not super expensive, especially if you can get them, because like there's a lot of play between China and the US and the rest of the world around neodymium, rare earth metals, and so on. So, but the magnets themselves for this kind of robot, they're not too expensive.
Gotcha. So in terms of the architecture of it operating at a micro fulfillment center, how many, what does the solution look like? How many robots? Is it a swarm that's operating, or
It's a swarm. It's always a swarm. Yeah. It can be anywhere from, say, 10 robots to 50 robots if you're talking about automating a couple of thousand of square feet and having, of course, a lot depends on how much vertical height you have, but we can use all of the vertical height you have, be it like 33 feet clear high or say 16 or 14 feet. It also depends on throughput. Higher throughput, you would need more robots. So the system is very flexible and elastic in this sense. We can simulate the throughput and the storage density and reactivity. And so a lot of those parameters you will know upfront. It will not cost you anything. The simulation is free, right? We can come back very quickly with preliminary results.
And speaking of simulation, you explicitly call out that InStock is about software, pushing complexity into software and simulation first design. You say on your website, you want to make, quote unquote, make it software. What it mean?
Well, first, the robot, you may just say it's a computer on wheels, right? So it has, it decides a lot in software. So for example, like when you drive, we don't have a rail to drive on, right? Rails, they cost money. They require tight tolerances and so on. For us, it's just autonomous vehicle. So when we are driving or when we are programming the drive of our robots, you apply more the techniques and experience from self-driving cars rather than from HVs. So that's one. It's like how the robot moves. That's one layer of software. It kind of lives everywhere, and including the robot itself. Then the next layer of software is how do you manage and control the behavior of a swarm? We call it squad because swarm is typically like of simpler entities, but it doesn't matter. So we pre-calculate the trajectories, behaviors, and of course, like this combinatorially, the space is very large. You can't pre-calculate everything. When you move through this combinatorial graph of situations, we can pre-calculate multiple layers into the depth of it. And then the final kind of layer, when you have already some specific situation, this is a layout of how bins are positioned. This is a layout how the robots are positioned. And this is tasks you need to accomplish. That already happens on the edge, on the server, on site. But it's using all of the information produced by the software on the back end that pre-calculated a lot of stuff for you.
Got it. So if you're deploying on a fresh site, you're deploying your solution. Walk us through the very start to finish. If I'm a micro fulfillment center and I go, this use case works for me. Maybe I'm an apparel fulfillment for a retail, and I want to use your solution. How will that work from start to finish of the deployment?
Yeah. So we'll start from getting some basics of your premises, right? Like how the room looks like. We'll immediately spawn like a simplified digital twin of what is going on. Then we'll ask for your data, like what kind of SKU profile do you have? Maybe your full SKU assortment. What kind of orders do you have? You should have some historical data. Based on
Mhm.
that historical data, we will do simulations within that digital twin, within that space. We'll say, okay, the grid may look like this. The robots you do need that many robots. Typically, the conversation is around peak hours, right? Because peak hours define the total demand from a system. Then we try to do quickly several iterations with the customer just to get on the same page of like, oh,
For the
this amount of
simulation?
yeah,
Yeah.
in simulation environment, this amount of robots would produce that throughput, that reactivity. It's not only throughput, right? Like there is a thing called reactivity, or I call it time to first bin. Basically, imagine system is idle,
Mm,
do nothing. You give it 20 orders
yeah.
at one point of time, like when the first bin of the first order will arrive. So there are
Mm,
especially for the businesses that have kind of tight SLA, say it's a, I don't know, 15-minute, 20-minute grocery delivery, 45-minute grocery delivery, urgent ASAP orders, that matters a lot. And so once we settle on parameters in simulation, we kind of trust, we put a lot of effort into our simulation. It's high fidelity. We know that we will be in the range of like plus minus 10%. Typically it's minus, but we will stay within 10% of what we promised. Then we obviously we have to discuss the cost. Very often, this conversation is very helpful to the customer because they start to realize how the net value is produced by automation solution. It doesn't matter this is in stock or any other solution. Just understanding the formulas. This is simple arithmetic, but there is still some gotcha moments when you
mm,
realize, for example, that okay, the number of hours the solution may operate plays a crucial role
yeah.
in how quickly you can recoup an investment or what kind of ROI you are getting. Once we are through dollars, then we actually can start implementing. There is a difference. Are you building a system that is lower than 12 feet or higher than 12 feet? Because the fire code standards but basically we try to produce as quickly as possible the documentation that customer needs to have to submit for permits. Like basically, you go to any contractor and they will ask you for three types of docs. It will be a structural documentation for structural permit, fire documentation for fire permit, and electrical permit. With electrical, it's super simple because we run on consumer grade 110 volts power supply and all of the jigs. And so that kind of goes away immediately. The complexity is equal to getting another couple of outlets within your facility. And it's structure and fire. So these two things are very much built into the architecture. So of our solution. So when we produce the
Mm,
documentation, there is a very high degree of confidence that you will not get into many, many loops of conversation with the authority having jurisdiction that it will just pass through in one iteration. So, but yes, the law is the law, right? The code is the code. If you're building anything that is above certain thresholds, you have to get structural permit. And if you are storing inventory above certain threshold,
Right.
you have to have fire permit received. But the permit sounds scary, right? But the permitting process may take a week or it may take endlessly. It all depends on how
Uh,
well you're prepared. Of course, there are jurisdictions where that just they want things complicated, but at least in the US, that's not a regular case, right? The jurisdictions they try to simplify. Maybe they don't try hard enough. That's a totally different question. But on your side, on the side of a customer and contractor, you have to be prepared and you have to come with good docs. And that's what we're
got
doing.
it.
We give you the solid documentation, engineering work that you don't think twice. You just go and submit for permit. Once the permit is there, we just install it. Install can take 2 days, 2 weeks, depending on the side of the systems.
Got it. So there's so much to unpack in what you mentioned. What I love is the lessons you're giving for somebody who's trying to launch a company, trying to develop a solution, whether it's in this space or not. You've thought about it from customer experience from start to finish. The simulation piece that is, correct me if I'm wrong, that's your key to customer adoption. You've
The
had
sales
to,
cycle, yes,
yeah. So that is a separate product in itself. I want to know
correct.
how did you build that capability? Is that in-house? You're using existing simulation solutions that are out there?
Well, we definitely look at every tool that is out there. But what's important to realize is that you have those tools that give you sort of like super sophisticated photorealistic picture, right? Let's say you have Unreal Engine, Unity Engine, NVIDIA Omniverse.
Yeah, yeah, yeah.
And they come from different environments, right? Two of them are coming from sort of like gaming world. NVIDIA comes from gaming and they want to sell GPUs. So it's like everything must be photorealistic because that's what consumes GPUs.
Yeah.
But if you're not NVIDIA and if you're a 3PL, much simpler models, still three-dimensional, may help you to understand everything about what you are getting.
Because
So
the
it's important to choose
throughput,
the point
yeah.
in between.
Okay. Yeah, that's a good distinction to make. When we think of simulations, oftentimes we're thinking of that omniverse side of things that, oh, you're creating a digital twin. And you necessarily don't need that. You don't need the photorealism, but it's more about getting the customer an understanding of what they're getting into, how their business would operate on your solution,
Yeah.
right?
And remember, maybe 3 out of 4 customers will say no, right? Because they're
Mm,
not ready. Robotics is not yet for them. There is no net value delivered at this current price level. It's fine, but this should be no based on some real analysis and not just kind of a rule of thumb guessing.
mhm.
The cost effective, fast, easy process of checking this in this sort of, you may say, simplified. Like the word digital twin is not specific enough, right? Because you can have a progressive level of detail in this twinning. Like,
Yeah,
of course, the word twin is almost like an obligation that it is a
yeah, yeah.
photorealistic. But let's call it digital model. And you don't have to have very detailed in terms of photorealism model, but you have to pay attention to details that matter, right? For example, geometry, obstacles, avoiding obstacles, sort of collisions. Like, is this enough turn radius? When you discuss turn radius, you don't need textures, right? Don't need super
Mm,
artistic
yeah.
lights in your room, right? You're just discussing. Sometimes you just need two-dimensional. So by having ability to manipulate those simplified three-dimensional models or two-dimensional models quickly, sometimes in front of a customer, with the customer, gives everybody confidence that what you're discussing is not just like a long loop of engineering effort, multi-department that is very prone to errors, but here it is. Here is a source of truth that then the robot will rely on because it's using the same model. The engineers will rely on for all other purposes, right? And there are no multiple versions of a truth. Like you have this one geometric version of a truth of what's happening, and it will be a source for all kinds of decisions later.
Got it. And in the simulation that you use for the sales cycle to map out the throughput and map out the layout for the operator of this is what your warehouse would look like once they decide to go for it, you're using the same model that
Yes.
goes into programming the
Yes.
robot to know what the bin
That's key.
locations are.
That is key if you want to have high fidelity, good promises. Because of the typical like problem, right, in this pipeline is that you're using one model to sell,
Hmm.
and not you, someone is using
Yeah,
one
yeah, yeah.
model to sell, and then a totally different model is used to program, to get a permit, and so on and so forth. And that process is prone to incoherent results, right? There is always
You're
will
not
be an excuse.
iteratively building on
Yeah,
it, and
yeah.
it's almost starting from fresh, and there's a mismatch of expectation from customer going, "This
Exactly.
is what
Every
I
engineer would
saw."
have his excuse, but as owners of the business that is utilizing automation, or as a management in
Mhm.
the vendor, we're not interested in excuses. We are interested in efficient process that is streamlined and doesn't produce like a lot of loops and circular references.
Got it. So let's say, thank you for laying out that whole journey. That makes it much clearer on how the solution gets deployed. Let's say I'm inspired by what instock.com is doing. I'm a founder. I listen to this podcast and I go, I can do a better job than Igor and instock.com team. I want to be a competitor.
Go
What's
for
the
it.
hard, yeah. So what would you say is the hardest part for them going into this? Is it replicating your robot, the simulation side of things, your software stack? What are they going to find the hardest, and where should they focus on? If you wanted to help your competitor out, what would you say?
Yeah. Well, if I want to help, not like my competitor or anyone who is going to produce solution for this area, for this domain, one of the hardest things here is to estimate how much effort and how much resources you need to put into producing certain level of the quality of the solution. Quality includes reliability, user experience, working in those kind of non-vanilla situations. And here you can very easily make a 10x mistake, right? Not like 30% mistake, but you can underestimate what it takes to produce this kind of solution on all levels: product, engineering, operations, deployment, right? All of that is important because your customers ultimately are interested in net value and not in robotics or coolness. Like coolness and robotics, this is a nice warm opening of the conversation. It lasts 5 minutes. After that,
Mm. So
the real
results.
people, they want to discuss like where the value is coming from. And to deliver value is extremely hard. As I say, it's very easy to be a roboticist. It's very hard to deliver net value to your customer.
Yeah, that demo to reality gap is huge,
It's
and that's
enormous. It's
into
enormous.
that it is 10x of what a
You
typical
know,
founder may. Yeah.
it's enormous and it's not very glorious in a sense.
Mm,
Like if you're an engineering minded, engineering type of a founder, you're not going to brag to your buddies about like I have this very nice error handling mode and my customers can now understand my error messages better, right? It's kind of not very
mhm.
sexy. And of course, like AI may help, by the way, in a lot of those questions in building a nice interface to your customers when robots interact with your customers. But again, you have to build it with customer in mind.
Mhm.
And that's what matters.
Yeah. So,
If you're not
speaking of
enjoying
that,
this part of the process, don't go into it.
yeah. And speaking of your customer, for them to close on the solution, what fear are they overcoming? Is it downtime risk? Is the ROI
Yeah,
skepticism, change
yeah,
management?
it's easier. Just put yourself in the shoes of real customer, right? Real customers, they have some operations going on, right? They have revenue, they have profit, they have machine is working. And the machine is working, not necessarily the machine is super robust. So there was some experience from the past. Managers, owners, they know that if you shake the thing too much, it's going to break, right? Or if you will disturb it, disrupt it. So that the number one concern is that, yes, on one side, I have to get the value, but I don't want to risk my operations. I don't want to risk existing flow of things.
Yeah.
And you have to give assurances and explain really what kind of measures you're putting in place so that the existing operations will not suffer.
Yeah.
Typically, like, doesn't matter what kind of solution that is, typically the usual measures are you start small, and ability to start small, but at the same time economical, is very valuable. You start small, you limit to certain, I don't know, part of the inventory or part of the warehouse, part of something.
Pilot it out in a
Yeah, but at
limited
the same,
capacity.
yeah, you create some forks so that there is a fallback scenario. And through measures like that, you can see that, okay, the risk is limited, it's manageable. The vendor is kind of underwriting that risk, but the value is big enough. And sometimes it's very big if you are kind of corporation with multiple facilities. And then it kind of tips the weight balance towards let's go for it.
Yeah. So for the deployment, are you typically the path to deployment is always pilot first? Do you ever
Almost
do
always.
full? Okay.
With a new
Yeah.
customer, always. Like, of course, if you worked with these customers for 10 years, if you have installed 20 sites for them, like installation number 21 may go much easier along some template, right? But when it's a new customer, and if we're talking about like a startup universe, almost every customer was new, then it will start with pilots. But it's important to understand like what is meant by a pilot. Pilot doesn't mean it's not production. It can be a real production in a real store, in a real warehouse. Just nobody will give you the whole operation just because of this risk. People will give you something, but it will be production, a real production with real flow behind it.
Do you prefer a customer to be completely greenfield, meaning they don't have existing operations? Is that a better
Not
scenario
really.
for?
For us,
Okay.
the brownfield scenario is better. We love to come and improve something that already exists and working. In greenfield, there are many factors that do not depend on you, how long they will build, right? And let's say you're ready to go, and then there is a 1 year delay because of anything, because of the land permits,
Yeah.
contractors, etc., etc. Right? So greenfield has its own challenges, and you want basically customers who are willing to give you maybe a smaller footprint, but they're ready to go today.
Yeah. And you claim 10x reduction in fulfillment costs, right? Where are this reduction actually coming from? Is it labor, space, from a CapEx perspective, or
It's a
throughput?
space and labor. Well, depending like what you're comparing. When I say reduction, the underlying assumption is that you have existing manual process. That manual process occupies certain area, has certain footprint, and you have some number of like resources involved, like people with some forklifts sometimes, or just people. And you're comparing to this new architecture of the process where system is much more vertical, storage is more vertical, so it occupies much less space. Yeah, and remember, you're paying something like $20 per square foot per year. So space is not cheap. Let's say it's not like a rounding error. And labor, very often the conversation is not that someone will cut labor. It's about that, oh, with existing labor, we can do much more. From existing facility, we can do much more. We don't have to move into another bigger room or another warehouse. We can do much more from what we have today here. And this ability to start small or go in chunks gives ability to build a chunk, transition some operation into it while the rest works well and like is untouched, and then build another chunk, and then build another chunk, right? So when you are installing an existing facility, you have to be careful in terms of, you cannot say, can you please vacate the half of the facility because I will be installing here. No, like you cannot say that. In the greenfield, of course, that's why like bigger companies, they love greenfield, right? Because they can be embedded into from the beginning, and they hate brownfield, but you can't sell a huge system into a
Yeah.
warehouse where every square feet is occupied.
Yeah. And at what scale does your solution break, your model break? Is it when it's too
It
small?
doesn't break at any scale. Remember, we're a very small organization. So if you would tell me, hey, can you install and maintain service like 3 million square feet warehouses? We would say, like, we have to grow as an organization immediately to do that. And there is certain limited speed with which we can grow. But it doesn't break in terms of technology, right? It's the maintainability principles are there. It just, you feel less the benefit when it's a million square feet warehouse, because in a million square feet warehouse where automation occupies half of it, a million square feet, you can allow to have maintenance people on site every day, 2 shifts with their own workshop, set of tools and set of jigs. This small maintenance team will be a rounding error in overall costs of a million square feet warehouse. So the benefit of being able to kind of maintain the site will be less visible.
Mm-hmm. And then do you think the future of micro fulfillment, of vertical storage, is it about better structures or better orchestration of movement?
If you say micro, it's about flexibility and cost. Maintainability is a big part of the cost structure. Because, like, why this maintenance on site is bad? Because it's just damn expensive.
Mm,
Just think about, like, you're calling someone. Well, again, back to fridges analogy.
yeah.
When your fridge or dishwasher is down, you're not gonna bring it somewhere to be repaired, right? You will call someone, and this will be expensive call. You will probably spend $200, $300, $400 on this call. Doesn't matter how easy is the fix.
Yeah.
It could be like 5-minute fix, but it still will be $300 at least if we're talking about North America, United States, California.
Mm-hmm.
So it's all about small and how to be efficient in small spaces.
Yeah. No, that's a real advantage, and that's the value that you're bringing into it, keeping it flexible, being able to deploy
You
it.
can also look at it from a customer perspective and customer intuition. How many people in this world, even in the, I don't know, logistics, warehousing space, have any intuition and experience of working with robots? Maybe 1%. The
Yeah.
rest, their best of intuition is like, oh, I have a vacuum cleaner, I have Roomba. When we think about humanoids or AMRs, like, we project certain things, and those projections, they mostly come from our experience as users, as consumers and customers, from working with existing hardware. What is existing hardware? Typically not mobile. Like, you come, you press a button, some kind of computer, or if it's mobile, like a mobile phone, right? You have to carry it. Doesn't have legs or wheels, and it does exactly what you told it to do. There's no variation, right? You know what to expect. You press a button, it does what you expect. So people project, and they have the same expectation about mobile robots. But even if you ask people to formulate, okay, what does it have to do when you say go? Like, where does it have to go? Where it has to drop a bin? There is no intuition. So there is a mismatch between, like, internal expectation that it must behave, it must do what I say, and basically how much in detail people can imagine what they want to do, what they want robot to do, right? Because all of the tools in our life, they're not autonomous, they're controlled. So when you
Yeah.
send someone on an autonomous mission, like, imagine you're sending a kid to push a cart and leave it somewhere and pull a bin from a conveyor and push on the cart. You think, like, okay, let's say it's a 12-year-old, 10-year-old kid. How well you have to define a task to have 99 out of 100 success of execution of that task?
Right. Super detailed. Yeah.
Yeah, you have to be super detailed, but you don't want to be super detailed. You don't have time to be super detailed. So
Mm-hmm.
robots, they are in a challenging space where they have to basically ask a question or pose the buttons and command in such a way that you're not spending too much time on defining everything that is involved in kind of successful mission, but at the same time, you match the expectation of a user. These are more like UI challenges, right? Experience challenges, but they're there and they also influence the success of your AI-driven robotic arm, right? So AI may be there, robotic arm benchmark may be there, but again, it's in deployment, something may not, like overall the success is not there because the user experience was not there.
Yeah. The training, is that a big factor in getting the user trained up for the deployment?
It shouldn't be. If you have to train the user, probably something is
For
wrong.
your system,
For our
in
system,
stock.
right? It should be so intuitive, and for other systems too.
Mm-hmm.
You may allow training in some super expensive processes. I don't know. You're dealing with mission critical vaccines in the fully frozen warehouse. Like, sure, you can allow training. Or you are storing nuclear material, some hazardous material. Okay, you will allow training. People have to be really trained well. When it's a regular 3PL moving regular e-commerce stuff around, then you shouldn't be training people for too long.
Yeah.
Like maybe
what
15 minutes.
Yeah. What I'm hearing is for deployment, you've considered it to be intuitive in terms of your pilot process. The person
Yeah.
is getting onboarded quickly
And also learning
scale.
as you go, right? Like the system should be forgiving in a sense. If you misunderstood something about the core concepts or the vendor was not perfect in explaining those core concepts, it doesn't create catastrophic results out of simple like human mistakes.
Got it. Yeah. No, thank you for taking the time, Igor. I know we're approaching time. This was very informational on how you're thinking about fulfillment, how the deployment process, the long journey that you have taken, you've considered the whole value chain that a customer has to consider. This is valuable for founders, for operators, for anybody who's within robotics. So this is good conversation. Before I let you go, I want to jump into the lightning round, a tradition here where I throw a whole bunch of questions at you really, really fast and get your first reaction. So are you ready to go into that?
Yes.
If you succeed with InStock, who is going to lose?
Traditional, big, old school automation vendors.
What existing system or business quietly becomes obsolete?
I would say asking people to push carts around should be obsolete.
Best thing about your job?
I mean, being able to bring something new to the world that potentially is very helpful and very impactful.
Keeps you going, gives you purpose, meaning, all of that.
Correct.
Best thing about being a founder, yeah. Most challenging thing about your job?
Well, it's unpredictability and uncertainty. It may take much longer than you expected.
Yeah. What would you say
Especially in robotics.
What's the most exciting, real development, not hype, that's happening in robotics from your perspective?
Well, the overall exposure of broad masses of businesses to the opportunity of robotics is exciting enough. I just hope that it will not produce some kind of a winter effect because of too many fails. We have to keep the snowball of accumulating value going forward.
What do you think is the most alarming thing about the state of robotics right now?
Well, I think the most alarming thing is the gap between what investors understand and know and the amount of money they deploy, with very little or shallow understanding of what's going on.
Got it.
It's like,
fair point. What feature about a robot signals that it is ready for the real world, that it's safety ready and real world ready?
When customers have something in their hands and they try to do something with that, the hype goes away, right? The coolness is a little bit in the back, and they try to achieve something. Exactly. Like they try to do something useful with it. And very quickly you see, is this going well or not?
The usability, trust, that is the marker. The look on the customer's face determines whether the robot is ready
Basically,
or not.
in other words, the things that will stick and will be successful are not those that ride on the coolness factor, are those that are useful and have good utility in normal life if you exclude the coolness, right?
Yeah. Yeah. What's one thing that you want robot to help you with in your life?
I definitely don't want any robots in my home besides vacuum cleaners. All right. Like I thought about like if I have an ideal humanoid in my home, what it would do. Humanoid to do is just to plug all of my devices, put them to charge in the evening.
Or the robot itself is charging
Yeah,
the
because that's my
devices.
responsibility. Like literally have to put 10 devices in the evening on charge.
Yeah. Speaking of robots being good at certain things, what do you think? What is one thing humans do better than robots?
Well, there are so many things. People, the way you handle objects with your arms, the way you understand nuances, how geometry interplays with forces, it's insane. Humans are so good into it.
Yeah, makes sense. Let me throw one last question at you, which is you go into the future, you visit 2050 and you've come back. What does the future hold? What have you seen?
There's so many futures that are possible. Well, I'm an optimist, pragmatic optimist, right? So in my version of the future, people spend more time on learning and understanding the world. Maybe we have a lot of things in space, like we move industry back into space. Again, with a net positive impact on Earth, and the humans are just kind of spending their time learning and doing work in some pleasant environments.
Cautiously optimistic that we are making the right decisions. We are learning, and we've learned from some of our mistakes in the past, and we're spending time in more positive pursuits.
I'm worried about the adverse effects of some confrontation where people like get. I mean, I'm myself from Ukraine. Obviously,
Yeah,
my people in Ukraine suffered much more than I did from the war, but like I've seen how we take some things for granted here in the US and Europe.
you're painting a picture that you're cautiously optimistic about especially considering the state of affairs where the world is right now. You're cautiously optimistic about humanity, where we're headed. We have to battle these instincts that we have, where we have short-term memory. We don't oftentimes are not looking at the bigger picture. Those are
Yeah,
some of
super
the
tribal and propaganda, and there are no easy solutions to that.
Mhm.
But hopefully, little by little over time, we'll come to a better place without huge crises.
And ideally we're able to learn. We can extrapolate, use a simulation of what could happen, and learn from our mistakes
Yeah,
before we make those mistakes.
that's why we have imagination. We just have to use it.
Yeah. I love that. Love your pragmatic approach to your company, your solution, your views on where humanity is headed, and your optimism, but also realizing that we have to put the guardrails in place. Or we have to fight for the future that we want. It's not automatically going to happen, right?
Absolutely.
And robotics is a tool in that space. It could help us or could make things worse.
Intelligence is a great, great tool for, on a personal level, for everyone to understand the consequences of actions and to plan and project into the future to help their imagination. That's my biggest hope.
Yeah. Well, thank you. On that
Ali,
note, I appreciate your time. This has been
thank
wonderful.
you very much for having me.
Of course, my pleasure.
All right.